Hello, everyone. My name is Zlatko, and I'm here with Helen and Dario. And let's start first with explaining what is Kubernetes, although I think most of you kind of know what it is and you have some touch with it. At its core, Kubernetes is an open source platform. It's designed to automate handling of containerized applications. Basically, it's making sure that applications you can run all over the cluster. You don't need to worry where they are, will they fail or not fail, and if they are on premises or in cloud, Kubernetes is there to cover you. Kubernetes is kind of operates on a declarative model. So you define the desired states, and then the Kubernetes cluster is continuously works to achieve that state as much as possible. Of course, some errors might happen, so that might not be achieved, but there's a fallback mechanism and the statuses that you can rely on. In general, on this presentation, we will touch a few ways of routing traffic in your applications with the HAProxy. From first time touch with Ingress, then we will talk a little bit about the future with Gateway API, and in the end, we will cover everything with the, let's say, the most advanced way with Fusion Service Discovery. Okay, so let's talk about first a little bit about Ingress and what can we do with the HAProxy. So HAProxy is kind of best known for its reliability and performance. So it kind of fits automatically all the needs and requirements to be an Ingress controller. So while using HAProxy in general, there's no really a difference in how requests are load balanced from, let's say, traditional standpoint of do. For HAProxy, it's not really important, are we in Kubernetes or barebone or VM or Docker images or, I don't know, anywhere. And HAProxy can handle all of those environments. Specifically in Kubernetes, since we know the high amount of traffic is expected, and the whole environment is kind of highly dynamic because of the high number of pod creations, updates, deletion, even the moving and reallocation of the pods. So I would say the HAProxy with its runtime API and hitless reloads, we kind of excel in such environment. As I mentioned, Ingress itself is an object. It's part of the API in Kubernetes, and in fact, it is the oldest API in Kubernetes for configuring incoming data routing. It has a relatively simple design. It's used to describe the traffic on layer 7, so HTTP. However, as many implementations, our as well can handle layer 4 traffic or TCP traffic, so that's not a problem. One of the biggest strengths of Ingress is actually that it's a standard and it's part of the Kubernetes API. So and it's quite stable. I think like 5 years ago, it's become V1, even though a lot of people even before used it in a beta status and it was quite common. In fact, a lot of things in Kubernetes is kind of beta state production ready. Yeah. So one of the biggest things that we might say, it's really has a simplistic design. You define routes and the service you want to connect to. And sure, due to its simplicity, not everything can be kind of configured. For that reason, we extended Ingress, as probably all other Ingress controller, we added a lot of annotations. And we have done that to unlock basically the full power of HAProxy, because annotations can also be set in multiple levels. So you could set annotation globally with config map, or just in Ingress level or service level. So there's really high customizability and complexity you can do with the setup. Over time, we saw that users are having difficulties with combining all possible options. For that reason, we introduced HAProxy CRDs that matches kind of HAProxy configuration sections. This allows users to fully unlock all the power that HAProxy has in different environments. And yeah, when I say all, currently not everything is still in CRD, but the next version that we plan to release will have that. It's important to note that the scheme or CRDs that we have are basically the same that you have in Data Plane API, and Fusion, basically. So across all our applications, you can do the setup and use the similar approach in all applications. And I think that's really nice because you don't need to learn another thing. It's basically just the same thing in different way. For example, compared to Data Plane API Open Scheme, for Ingress, you just add metadata that's actually Kubernetes required, nothing else. Everything else is pretty much set up. Yeah. So one of the big strengths, I would say, for our Ingress controller is that we wanted to avoid extra hops, so not routing traffic to the service, but directly to the pods. And there are multiple reasons why. So I would say latency, and you kind of avoid one extra hop. But you also allow controller to directly see what's going on because you have checks and everything, and it can respond much faster. Plus, if you use service level balancing, you're kind of limited what you can do and what you can do with it. Just as a side note, one really extra cool feature, even though Ingress control is primarily designed in a way that you can run it and you need to run it inside of Kubernetes, ours can actually run in external mode. So you can actually use it and start it outside of Kubernetes. So it doesn't need to be inside. How is that achieved? It's a little bit complex topic, but we have a really nice blog post on our HAProxy.com page. So I think that's explained. There are some tricks with networking, but it's pretty simple. In general, I would say that Ingress controller allows any kind of traffic routing, and at the same time, it allows you to configure basically everything that you can do in HAProxy anywhere else. So you're not limited with what you can do with Kubernetes objects and its API. We have an extension that allows you to do that. They are primarily highly interesting in terms of customizing routing, but also for security purposes like rate limiting, bot protection, and WAF. I would say that's kind of the overview of Ingress controller. I will leave now floor to Helen to talk a little bit about future with Gateway API.
Thank you, Zlatko. Okay, let's now jump into an overview of what the Gateway API is. It is a Kubernetes networking API that is designed to eventually replace the more limited Ingress API. It was launched in 2019, and it did reach V1 in 2023 for its core concept, the gateway class, HTTP routes, as well as reference grant. However, as many other features remain in alpha or beta stages. So what are the key features? It has a role-oriented design. It splits responsibilities across different teams. It is extensible. The Gateway API is not built in Kubernetes, but it uses custom resource definitions, CRDs, to define the various objects. Unlike Ingress, which was limited mostly to HTTP, the Gateway API introduced, for example, TCP and UDP routes. It also offers a cross-namespace support. The routes can exist outside the gateway's namespace. So compared to Ingress, the Gateway API is designed in a way to allow multiple teams to handle their own parts of the routing. So for smaller companies, that would probably be the same person. But however, larger organizations would typically have dedicated teams. For example, that way, developers do not need to know or even worry about the infrastructure part of the routing. So what are the plans in HAProxy for the Gateway API implementation? As Zlatko said, Ingress controller was developed for more than 7 years now, and we learned a lot in that period in terms of customer needs and usage. And we will apply all lessons learned from the Ingress controller and from other projects we did over time into the implementation. One of the main lessons that we learn is to think big, really, really big. No one did foresee the scale at which Kubernetes would be used, neither did we. One huge part of a positive experience is API experience, is observability. We need to be easily able to track and see how the traffic flows. One big part of this is logging and metrics. For example, we experienced that just having log levels is not enough. And we plan to extend this to define a lot of more of fine-tuned settings for logs and metrics especially. The advanced configuration of the loggings will be done dynamically and will be as easy as updating a custom resource. We will also benefit from the replay tool that was developed for the Ingress controller and that Zlatko will explain a bit later during this presentation. This will allow us to test our implementation for humongous clusters. Of course, we will also rely on dedicated HAProxy CRDs, similarly to what we have done for the Ingress controller, to fully customize all HAProxy configuration sections. As the gateway API is evolving, we will also evolve with it. The parts that are now in alpha or beta will be gradually updated as soon as they upgrade to V1. So for community users, we are announcing that a new product that we have started to develop, it's a HAProxy Unified Kubernetes Gateway. It will offer a gateway API implementation with a design very similar to our current Ingress controller. As for the Ingress controller, this gateway will also run in a single Kubernetes cluster. On the enterprise side, the unified Kubernetes gateway will be integrated into Fusion. It will offer the support of multiple gateway classes, and the integration into Fusion will automatically bring all the powerful features of Fusion that you were shown during these days at the conference. Among the most exciting ones for the Gateway API, we can mention that we will get a federation of multiple Kubernetes clusters, which is a huge plus, and also an enhanced synchronization between all the HAProxy nodes. I will now leave the floor to Dario that will talk about the next option, the service discovery option.
Thanks a lot, Helen. So we already had some talks about the Fusion control plane. So it's our single pane of glass to orchestrate a lot of HAProxy instances. So it's great to be also here to talk about Kubernetes and Fusion control plane because there is a sort of similarity. In Kubernetes, we are using pods. And we are orchestrating pods. Instead of with Fusion, we are orchestrating an instance, a set of instance of HAProxy. And in Kubernetes, networking is very complicated. You know, I used to be a site reliability engineer, and there are plenty of pain in Kubernetes. We got the storage, but we got also the network. So what we learned by interacting with the community and also with our customers is that we need to create a sort of framework to empower them in creating products on top of Kubernetes and their own business case. So with the Ingress class and also with the Gateway API, we saw something similar with the platform engineering. So essentially, we have developers, we have also admin, we have platform admins, and we need to empower them in order to let them use Kubernetes without any issue. Kubernetes has multiple ways to do networking and also ingress and load balancers. And for the sake of time, unfortunately, we can just see 3 use cases. But I'm pretty sure that these are pretty interesting for all of you which are using Kubernetes. And we have the post discovery. We got the load balancer and the multi-cluster routing. Right now, we just talk about one Kubernetes cluster, one controller. But the real power of Fusion is that we can tame a fleet of Kubernetes clusters. When I was doing site reliability engineer for Kubernetes, just having one cluster was very painful. So you can imagine what's going to happen if you have dozen, 100, or 1,000 of Kubernetes clusters. So let's start with the pods discovery. We all know that in Kubernetes we got pods. The pods are our applications, and we want to discover them. But it sounds pretty similar to an Ingress controller, right? Well, in Fusion, essentially, this is our backbone to create something for your use case. So essentially, in Fusion, you can discover pods according to the services. And these services, they can be node port, so we can easily target the node ports, or we can target the pod IPs. You can do that easily by using the services of Kubernetes. And we got also all the features powered by HAPI, so HAProxy Enterprise Edition. And what I really love is that we have the same concept of platform engineering in Fusion. So essentially, you have the developers, they deploy their own applications, and then the cluster administrators, the Fusion cluster administrators, they can specify if we need a transformer. So if we need to create just a backend, so an HAProxy backend, or do we need frontend and backend together, or we can use the fast backend transformer. So we are going to have also a very interesting session by PayPal, which is using, we already know that, they are using Fusion Control Plane, and they were looking for a solution to tame thousands of Kubernetes services. So it's very interesting because we work together with our customer, trying to understand their needs and address their needs scale. So pod discovery, you can use that to target any pod and easily have a sort of building block for your own service mesh. But my background has been site-bit engineer. I was using the cloud, but I was building the cloud for customers. And we all know that cloud is very cool because in the cloud, we need storage. We just need to create the persistent volume claim, and we got the storage. But you can imagine that if we need a load balancer, we need something that drives the external traffic inside of my Kubernetes cluster. So I'm talking about the load balancer. And with Fusion, essentially, we implemented a native support for Kubernetes where you can define an IP definition. So you can say, I want to get these IPs automatically assigned to my service of type load balancer. And trust me, on-prem, this is very hard. So with Fusion, we are making that simple. You see here that we got the IPAM definition. That IPAM definition is cluster scoped. So it means that also here we are addressing the platform engineering division. So it's a cluster resource. So the cluster administrator can define for each cluster the ranges of the IPAM. And then the developers, they just need to create the service with a spatial annotation. And for magic, what we are doing is that we are automatically assigning the IP to that service. And that service will be then backed by one of the HAProxy instances that we are empowering and coordinating with Fusion. And also, we got another very taming problem with Kubernetes because it's multi-cluster. So when I started my journey in Kubernetes, I was managing just a single cluster, and I get my hair lost. What you can imagine what happens if we have multiple clusters. I already lost my hair, so I need to find another pain. Anyway, with Fusion, essentially, we have multiple ways to target not one, but a lot of Kubernetes clusters. And we have also here, I'm sorry, just 3 examples, but they are the most important one because we have the active. Everybody knows that. And it's very complicated because maybe you have a team that needs to scale their applications across a fleet of data centers. And we all know that you can do is that active, passive, but also active, it gives you the chance to scale your applications. And this is easily covered by Fusion. So when you create a service discovery, resource definition, you can select 1, 2, how many Kubernetes clusters you want. And we are getting a unified configuration tracking all the pods. But we support also the active passive, and it's up to you. So Fusion is not just a product. As I said before, it can be used to create your own business logic. And the active-passive, it will be very interesting, especially if you have workloads which are relying on the state. Because in the end, everybody would like to have storage active, but sometimes there are some fallacies of distributed computing. So what you can do with Fusion is that we are tracking one cluster and another one, and you have the switch to forward all the traffic. This could be very interesting also to do a sort of A/B testing in real life. That's simple, thanks to Fusion, always using the Kubernetes primitives. So very, very interesting. And last but not least, the multi-region. So as I said before, we were used to run Kubernetes on the cloud because it's that simple. We are living in 2025, so Kubernetes is not complicated anymore. Maybe, who knows? I hear some laughs. So yeah, it's complicated. It's not stressful at all, Dario 46. But essentially, one of the use cases that we have is that we want to have multi-region, where multi-region could be even multi-cloud, so AWS, Azure, DigitalOcean, Oracle, but even on-prem. So with Fusion, you can get multi-cluster routing easily for the cloud and then on-prem, and you can create your own network mesh. Of course, it really depends on the network, but this is feasible. And what I really love about Fusion is that essentially it has been designed according to the customer needs and also to the experience we witness as Kubernetes developers. What I really love about Fusion is that we can have the same experience, networking experience across the infrastructure. It doesn't matter if it's on-prem, if it's AWS, if it's Azure. We are simplifying because we are creating an abstraction for each cloud provider. So essentially, it's like Kubernetes. We are using Kubernetes because we don't want to get an infrastructure lock-in. What we are doing with HAProxy Fusion control plane is that we are taming the networking in Kubernetes. And maybe I spoiled a bit about the lessons learned, but I'll pass the control to Zlatko.
Yeah. So I want to mention a few things that we learned over the years because we kind of are involved in Kubernetes for a longer time now. Let me start with first things. So both Data Plane API, Fusion, and Ingress Control share definitions for customization of everything. As I said, mentioned before, we have CRDs in our case, and Fusion and Data Plane has the open API scheme there. This allows you a lot because you are, even if you are switching across our products, you are always kind of familiar with everything that is offered. Sure, for some, as I mentioned, for Ingress Control, due to Kubernetes nature, you need to access some extra data, like metadata, basically. But the core is the same. So what you see in Data Plane API and what can you do with Data Plane API, you should be able to do it in Fusion, and also you should be able to do it in Ingress Controller. However, also, plus on top of that, technology has changing constantly. And beside that, our understanding of the whole process and how routing traffic in Kubernetes has also been greatly improved. So one of the things that we kind of learned is that, and that's kind of quite obvious when you go to the conferences and ask people, how do you use Kubernetes? Everybody's practically saying, oh, we love Kubernetes, we use it Kubernetes. However, we have our own use case that not exactly fits the needs. We have there this and that, left and right. It turns out that like 90% of people actually have something that they have customized or need and have desire for that. That's why I think the power of CRDs and the ability to have full options from HAProxy is highly useful because you are not limited to what you can do with our kind of controller. So one of the biggest challenges that we had is actually troubleshooting. Why? Because Kubernetes clusters are only getting bigger and bigger and bigger. So we have more metric data, we have more understanding what's happening, and metric data can be really helpful when you are bisecting issues. But as clusters grew, we kind of at one point reached the point where complete replications or simulation what is going on has become the challenge on its own by itself. So for that reason, we expanded over the time what we can do with logs and metrics in Ingress controllers, and I'll explain in a couple of slides what is the idea. But the point is, you can use kubectl, but there's so many logs, there's so many things that it's practically impossible and unusable to one extent, especially if we want to really troubleshoot what's really going on at certain points of time. So we allowed the logs, of course, to be pushed in various different databases, so that's not a problem, and metrics as well can be pushed basically anywhere. It depends what you actually need. And we use that system to create sort of a replace system. So what is it? It's basically primarily now designed for Ingress controller because Gateway API is in works. But size of Kubernetes is now basically not really relevant to us because we can easily reproduce the cluster of any size. So what's the idea? Idea is we log all Kubernetes relevant events that we have because we have the ability to do that in Ingress controller. And just on one single machine, or as you see on multiple ones, because we need reproducibility, we can reproduce that state. And we can do it as many times as we want. We can stop the world, we can see what's going on, we can examine everything. And that is highly useful to us. For example, we can try to generate any kind of cluster in a lab environment. But we all know that there's million tiny points, million tiny configuration that you cannot really reproduce, especially from customers that have high clusters. Even if they are highly detailed in telling you what they actually have, it's pretty much hard to reproduce huge clusters on the scale they have. Real data and real complexity now has become almost impossible to replicate. But I say impossible to replicate, but not to reproduce. Why? Because with this system, we can do it, and that's not a problem. And for example, we had one specific customer that has a problem. It was really complex system with a huge amount of annotations on multiple levels. They used practically all features they can, and just having to figure out where the issue is because the update was a bit on time, not expected. So we needed to improve things. This kind of system allows us to increase and see what's going on perfectly because we have been able to literally jump into their production, but not touching their production. And just for example, the whole update procedure this year was improved like 450 times in speed. So not a small amount. We actually did it really, really fast. So in the end, we have multiple options how you can use HAProxy in Kubernetes. And the best thing, I think, is to have options. So you don't need to pick. I think we have a little bit for everyone. For community, we kind of focused on having multiple projects. But for enterprise, Fusion is the one that is centralized place and it's centralized control plane. We kind of done overview, but the story for Kubernetes is not done here for Kubernetes. As a real world examples, because I think the best way to kind of see what's going on is to allow other people to talk how they use us. We will have two presentations today. One from PayPal to see how they use Fusion Service Discovery, and another one later in the day from DeepL about their usage of Ingress controller. So, thank you.
Amazing. These three. So we do have probably one or two questions. If there's some in the audience, go right ahead.
So thank you for the presentation and the work. First, do you have any date for the release of this new Kubernetes community controller?
Yes, soon.
It's on the
Trademark.
roadmap. That's my phrase.
Yeah.
No, but something more important. Yesterday we saw that we have coming in Fusion a wonderful security control plane that allows us to configure the entire stack. Will this apply as well to Kubernetes workload that we can configure?
Well, security is highly important for the company, so absolutely.
That's amazing.
Maybe you have time for one more in the audience if we have one. Going right over here.
Could you explain just a little bit more about the replay system? Is that something that the user captures on their end and sends to you for diagnostics?
Yeah, I mean, we need to configure logging system in order to capture all the data that we need. So primarily Kubernetes events, so basically what's happening with Ingress, what's happening with services, pods, endpoint slices, and all the data, relevant data that we have. They can send that or store that anywhere, but the point is they can then pack it somehow and send it to us, and then we can deal with and handle everything. I hope that explains it. Or
Thank you.
yeah.
And one in the stream. I swear this didn't come from the sales team, but what's the biggest advantage versus the competition? Other competitive solutions.
I would say it's the same as for HAProxy everywhere. If you need reliability, if you need performance, we got you. Simple as that.
These three, I'm confident. Awesome. Thank you.